Okay, so we're going to talk about slope-intercept form today, and there's going to be a lot of vocabulary. First, let's just go ahead and write the formula equation, better yet, for the slope-intercept form. So y equals mx plus. Now, in reference to the formula itself, m is our slope, but there's a lot of different terms we can use for slopes. When we talk about definition of slope, there's a lot of different ones. My personal preference is rise over run. You may also see vertical change over horizontal change, very similar to that. Other things for slope, other references, the word per. We've talked about this a little bit in class. The word per is change, so it often refers to some sort of rate of change. So anytime you see rate or change, the word per, that implies slope, often used in word problems. Other things you might have seen are symbolic, change in y or delta y over change in x or delta x. That's a Greek symbol, Greek letter. It just means change in. And then finally, you've probably seen the formula, my least favorite of all of them, y2 minus y1 over x2 minus x1. Now, again, we introduce all these different verbiages because depending on the problem itself, you may see it represented in different ways. And then B is our intercept, more specifically our y-intercept. Okay, why is it our y-intercept? Because it's on the y-axis. Well, what do we know about the y-axis? The y-axis has a coordinate 0, and in this case, we're using the letter B. So because x is 0, it's often referred to as the 0 term. Other things you might see with this, starting point in word problems, our starting point, or in other cases, our initial value. So again, different terminology that can be used here for the intercept. So what we're going to do is we're going to look at a couple of different problems. First, we want to look at graphing when it's in slope-intercept form. So let's say we're given the equation y equals negative 3/4 x minus 5. So again, depending on how you think of it, this is my y-intercept on the y-axis, or my starting point, my 0 term. So what I'm going to do is I'm going to go to negative 5. So I'm going to expand my graph a little bit here so I can see my values. So I go to negative 5 and I put my point, my starting point. There we go. Okay. Then I use my slope. Now there's two ways you can do this. You can do this as is, okay? So negative 3/4. So that means I'm going to go down 1, 2, 3. 1, 2, 3, 1, 2, 3, 4 to the right. Another way I could think of it, I'm going to rewrite this. Negative 3/4 is also 3 over negative 4. Those are one and the same. So if I go back to my starting point, that means I would go up 3, 1, 2, 3, and to the left, 1, 2, 3, 4. Either way is correct. Then what do we want to do? We just want to connect our points. Now, this is not going to be straight because I can't use a straight edge, but that's not too bad. And then we put arrows on both ends. Let's look at another problem. What if it wants us to actually write the equation, given different information? So let's say we're given 2 points, 5, 4, and negative 1, 6. And it wants me to write the equation in slope-intercept form that passes through those points. Well, here's why I don't like the formula. And you could use the formula for slope if you wanted to. I just like to think of it as change in y over change in x. So I just do this. How much did my y change? It went up 2. So I'm going to put plus 2 right here. Oops. So plus 2. Let me erase this down here. Okay. Then I look at my x's. What did my x's do? My x's went down. How much did it go down by? Went down 6. So change in y over change in x. Now, again, you can do it however you want to. That's how I like to think of it. So my change in y was positive 2. My change in x was negative 6. If I simplify that, it's negative 1/3. Now I've got to find my starting point. So I'm going to show you a couple of different ways you can do that. So I've got y equals negative 1/3 x plus b. So one way you can find your starting point is you can substitute one of the points into the equation. So this would be my x, this would be my y. Plug those into the equation. So I have 4 equals negative 1/3 times my x now, which is 5, plus b. Now I can work that equation and solve for b. So I'm going to slide this up here. So if I solve this for b, I have 4 equals negative 5/3 plus b. Add 5/3 to both sides. And if I do that, that's get a common denominator. You can use your calculator however you want to do it, but that would be 17/3 is b. Personally, if you're graphing, it's probably better to do this as a decimal or mixed number. So I would probably say that's 5 2/3.